Hi friends, this is Indranil back again. Well, first of all, I would like to thank you all so much for liking my previous video, which was for microcontrollers. I never expected this kind of response, frankly speaking, and I'm really honored to see such a response from you guys. So today I'm not here to demonstrate another video for microcontroller. However, I'm here to share my knowledge little bit regarding pointers and linked list, because I believe that's the most daunting topics for the beginner programmers. So thanks once again. Let's begin today. So I'm using Microsoft Visual Studio, and let's create a new project. And this time I'm going to use C++ because in .NET and C Sharp you have the data types already built, such as tags, queues, lists, dictionaries, all these data types which are introduced in .NET libraries. They use pointers somewhere in the background to create the structure, right? So one must understand how these pointers work and how the linked lists are created. All right, so let's jump into a Windows 32 console application, and I'm naming it pointer tutorial. You can name it anything you like, and let's not create a directory solution. And we'll create a empty project here, okay, so that you don't get any fancy stuff there. Okay, so our solution is created here, and let's create a new item. We'll add a new source file, a CPP file here, and I'm keeping the name as source.cpp. If you want, you can rename it to whatever you like. Okay, I hope everybody is able to see the screen. So I'm adding few header files. So this is a basic stuff, like most of you know, to add header files and the namespace, the standard namespace. So let's begin with what are pointers. So pointer is another type of variable which actually holds the memory address of another variable. So let's say we have a main function here. Okay, so I have a variable named a that has a value of 10. All right, so I can simply output the value of the variable is a. So if I run this program now, I'll get a output that will show me the value of a on the screen, like that. Okay, there is nothing fancy as such. So why do we need pointers? So pointers makes our life easier. We can point that pointer to any memory location we want, and we can create stuffs like linked list. And the major benefit of linked list is it can expand dynamically. So unlike arrays, because arrays, they are contiguous memory locations. So if you have an array of 5 elements, so it will be starting from memory location 100, let's say. So it will be 100, 101, 102 up till 104, right? But in case of linked lists, the nodes can stay in different memory locations, and they need not to be contiguous by any means, and the chain is built with the help of pointers. So how do we initialize a pointer? We put the data type of the pointer, and make sure that the data type of your pointer should match the data type of your variable. So in my case, my variable is an integer type, so my pointer has to be an integer. So I can name it anything starting with an asterisk. So After a space, I put an asterisk here, and I can name anything like pointer, and it will point to the memory address of my variable. So the address is indicated by this ampersand symbol. All right. So it's always recommended to initialize your pointer, otherwise it can be a wild pointer. I mean, it can point to anywhere, and you will not be able to locate it, and it will lead to memory leakage and all that weird stuff. Okay, so in case if you don't have any variable to initialize with, you can simply point it to null. So null is a inbuilt memory location, and it has a definite memory address, and it will make sure that your pointer is not lost. But in our case, we'll point it to the memory address of the pointer A. I'm sorry, the variable A. So if we want to get the output of the value stored in the pointer, what we have to do, we have to simply reference that pointer like that. And if I run the program again, it will give us the same result. Okay, the value of the variable is now getting fetched from this memory location, because pointer, it does not have its own value, it simply points. So if I want to check what's the memory address of the variable A, what I have to do, I have to simply type the memory address of the variable is pointer. That's it. Oh, I missed /n there. That's pretty hard to read actually. I'm sorry. So now if I run the program again, so this is the memory address for the variable A that we have declared here. Alright. So this is the basic concept of pointers. I'm sorry. Just give me a second. I'm sorry for that. Something went wrong with my microphone. Okay, so like we were discussing, that this is the basic need of pointers. Okay, so now I'll show you how you can create something known as linked list. So linked list, if I just show you what it looks like. So if I open a paint here, and so let's say I have 3 boxes, and these are called nodes, right? So in case of linked list, there are nodes which store data and the next memory location. So it will have 2 sections here like this. Alright, so one will have the data and the other will be the memory location. Please forgive me about this writing. I'm doing it with my mouse actually. So this block will have the actual data value, like 1, 2, 3, 4, whatever the value of the variable is, and this will point to the memory address of the next node. So this is node number 1, this is node number 2, this is node number 3. Similarly, the second node will have a pointer pointing to the next memory location. And let's say if this is the last node in that list, it will point to null. Alright, so we can create a similar structure using pointers, and I'm going to show you that. So let me just remove everything here. So starting with a basic structure here, I hope everybody knows about structure. So structure is again another data type which can store elements inside it of different data types. So I can name it anything like book, right? So it's a structure of book, and book will have a page number, and let's say that's it. I have only one variable to make things simpler, and it will have a self-referencing pointer. So I'm naming it next node. Okay, so this pointer is actually pointing to the structure itself. And let's say I create a global pointer that will be my first node. Okay, so my first node, I'm gonna change the first node each time. So my last node in that list will be pointing to null. Okay, and initially let's initialize it to null because I don't have anything to point to. Right, and I'll create a function to add nodes. Okay, and I'll put the data in it. So let's create a temp pointer that will hold the value of my first node, whatever it is. Okay, let's comment it out. To hold the value of my current first node, whatever it is. Okay, so let's check if temp is equals to null, whether it is null or not. That means there is no node in the list, so create one. Alright, so how do we create one? Is by with a new keyword. Alright, so new book creates a new instance of that book in a new memory location. I'll show you that in a moment with the help of the inbuilt debugger. And how do we point to the elements of a structure using pointer is using the arrow operator. Is this operator. So you can reference to anything you want. If you don't want to use arrow operator, what you have to do, you have to enclose this pointer with an asterisk and then use a dot operator, which will give you the same result. But in case of pointers, it's more of a syntax that you can call it, and everybody uses the arrow symbol. It's much easier to remember. So we'll use the arrow and we'll point the I will access the page number attribute, or the element rather, and we'll fill it with the data that we will get from here. And so this will be my first node, right? This is my first node, so it has no other node to point to, so it will point to my null. Okay, so now I have to store whatever there present in the temp node into my first node, because this is a temp variable, right? And it will get destroyed whenever this function call is over. So I have to save it somewhere. So I'm saving the whole data, including the page number and the next node information, into the first node, because that's my first node and that's how it's created. So let's say if my temp is not equal to null, that means there can be one or more nodes present inside the list, right? So what we'll do, we'll again create a new book, because of course we have to create a new node. Alright, and in this scenario we already have a first node in the memory location somewhere. Okay, so again temp page number will be data, temp next node will be my first node, my current first node will be my next node, right? And my first node will become my the temp will become my new first node. And make sure you do this assignment before you run this assignment, otherwise you will lose whatever there is inside the you will lose the entire chain if you run this code first and the code later. It will make no sense. Right, so once this is done, simply return the first node. That's it. Right, so this function is over. Now let's run our main function. Clear screen. I think it's not working. Anyways, never mind. So what I'll do, I'll simply run call the add node function. I will put in some values. Alright, so let's make it 25. This is 35. Okay, so now I'll put a breakpoint here so I can show you how it's functioning. Right, let's run the debugger. Alright, you can see the arrow here, so it has reached this point, and inside this watch section I'll add the temp variable and my first node. Alright, because those are the only two variables which I'm dealing with. So currently this line of code has not yet executed, right? But you see the first node has already been assigned the null value. If I expand this, it points to nowhere. It's a null location. So now if I press F11, it will execute that line, and you will see the temp variable has been assigned a null value because my first node is null. So we'll check the condition. Yes, it's true. So create a new temp, a new book, I'm sorry, and this is a new memory location which has been allocated to it randomly, and it has no page number value and no next node location. Okay, so now page number has been given. You see here it's assigned as 15 from the first function call. Next node to null because there is no other node, and you see my first node is still pointing to null, and I have to put the value there. So there you go. So now my first node is 15 and it's pointing to the next node which is null. So I returned the first node. Now it goes back to the second function call, goes back in here again, assigns the first node to the temp variable. You can see all the progress here. So now checks whether the temp is null or not. No, it's not. So it checks if the temp is not null. Yes, it's not null. Creates a new book, assigns the page number 25. So it's pointing to the next node, is pointing to the previous node, that is this one. You can match the memory address 49F8. It's pointing to 49F8, and this new location is 79D08. So now I'll assign the whole thing back to the first node like this. Return the first node, go again, check it's not null. Yeah, create a new location, add the data 35, point to the first node, and the entire chain is there for you. So you see the topmost node is the last one that we called, that's 35. It's pointing to the next node at this memory location with the value of 25, and it's pointing back to the last one, which is 15, which is then pointing to null. So this is how the chain looks like. So this is 35, this is 25, this is 15, pointing to null. Alright, so this is all about pointers, right? And in this manner, all the data structures like lists, stacks, queues, all those can be created, and I'll show you how to create the stack data structure in the next tutorial maybe. So for the time being, if you have any questions or if there is anything you do not understand, please drop your comments below and let me know what you want to see in the upcoming tutorials. I will be sharing uploading some tutorials related to game programming with Unity, because I've been doing that for quite some time now, and I would like to share my knowledge that I acquired during these days, and I hope you will like it. So see you guys next time, and till then, have a great day.